So let's continue. We saw what integers are. So now we'll see some operations on integers. So addition. Let's begin. Can we add natural numbers? This is one question we can ask. So adding a natural number, say 7 to a natural number, means we move 7 units to the right of the number. Adding 7 amounts to moving 7 units to the right of the number. So similarly, we can add natural numbers. For example, 5 plus 7 equals 12. You can think of it in terms of apples. 5 apples. 7 apples. They give total of 12 apples. If you start at 5, you can also interpret 5 plus 7 equals 12 in this way. If you start at 5 and you move 7 units to the right of 5, then you get to 12. So 5 plus 7 equals 12. This is addition of natural numbers. Can we add natural numbers? This is how we add natural numbers. And an observation: 0 plus a equals a plus 0 equals a for any natural number a. Okay, now we can ask, can we add integers? First we asked, can we add natural numbers? Now we are asking, can we add integers? So adding a negative number, say -3 to another number, means we move 3 units to the left of the other number. So for example, adding 7 means moving 7 units to the right of the number. adding minus 3 means moving 3 units to the left of the other number. Adding 7 is moving 7 units to the right. Adding minus 3 is moving 3 units to the left. So this is how we add integers. We can add any two integers. Example, 5 plus minus 3 equals 2. We move 3 units to the left. And we get 2. So 5 plus minus 3 is 2. We write 5 plus minus 3 equals 2 as 5 minus 3 equals 2 for convenience. Okay. Another example. 5 plus minus 8 is minus 3. If you begin at 5 and you take 8 steps backward, you get to minus 3. So 5 plus minus 8 is minus 3. So this is how we add any two integers. We can also take another example where both are negative, like minus 3 plus minus 8 is minus 11. So we can do the addition in a similar fashion. We move to add minus 3, we move 3 units to the left. To add a number say plus 7, to add a number say 7, we move 7 units to the right. Okay. This is how we add integers. Observation. A plus minus a equals 0 and minus a plus a equals 0 for any natural number a. Because if you begin at a and you take a steps backward, you get to 0. Or if you begin at minus a and take a steps forward, where a is a natural number, we get to 0. So a plus minus a is 0 and minus a plus a is 0 for any natural number a. Okay. Now we can ask, can we define minus a for any integer a? For example, what is minus of minus 5? Okay, we started with can we add natural numbers, then we moved on to can we add integers. Now we are asking, so we know that minus of an integer is already defined. Minus of a natural number is already defined. Minus of 1 is 1, is this number. Minus of 2 is this number, the one to the left, and so on. But can we define minus a for any integer a? For example, what is minus of minus 5? So we'll give a natural definition. For any integer a, we define minus a to be the unique integer box such that a plus box equals 0. So for example, minus of minus 5 equals 5 because minus 5 plus 5 equals 0. Minus a is that integer such that when you add that integer to a, you get 0. So minus of minus 5 is 5 because if you add 5 to minus 5, you get 0. So minus of minus 5 is 5 by this definition. So you begin at minus 5, you take 5 steps, you end at 0. Hence minus of minus 5 is 5. So minus of, say, minus of 2 oh, let's not go into that. Minus of 2 is anyways minus of 2, right? Okay, let's see. Minus of 2 as defined above agrees with the usual definition of minus 2. It is the unique integer box such that 2 plus box equals 0. So if you begin at if you begin at 2 and you take 2 steps backward, then you get to 0. So minus 2 is the so-called additive inverse of 2. It agrees with the usual definition of minus 2, which we saw when looking at integers, right? Okay. So in general, what is minus a for any integer a? Minus a is that unique integer box such that a plus box is 0. This is the main thing. Okay. For any two integers a, b, we have the notions a plus b and minus a, right? We have the notion of adding two integers and we have the notion of taking minus of an integer. So we can ask, what are the properties of these operations? Within this we can ask, does order matter? When adding integers? So there is an observation which we can make. It is called commutativity property. For any integers a, b, we have a plus b equals b plus a. For example, minus 2 plus 5 equals 5 plus minus 2 equals 3. So minus 2 plus 5 means we start at minus 2 and take 5 steps. Then we'll get to 3. 5 plus minus 2 means you start at 5 and take 2 steps backward. You again get to 3. So minus 2 plus 5 equals 5 plus minus 2 equals 3. And in general, for any integers a, b, we see a plus b is b plus a. Okay. Now, so does order matter when adding integers? So the answer is no. Or we can just leave. This is clear from the observation. Order doesn't matter when adding two integers. Then does grouping matter? Wait. Does grouping matter when adding integers? So we have an observation. This is called associativity. For any integers a, b, c, we have a plus b plus c equals a plus b plus c. So grouping doesn't matter. For example, 3 plus 5 plus 9 is 8 plus 9, which is 17. 3 plus 5 plus 9 is 3 plus 14, which is 17. We simply write 3 plus 5 plus 9 equals 17, and we don't need to put any brackets, any kind of grouping. Whichever way we group and add, we will get the same result. Okay. And so grouping doesn't matter, order doesn't matter, and grouping doesn't matter. The fact that order doesn't matter is called commutativity, and the fact that grouping doesn't matter is called associativity of addition. Okay, so we have an example or an observation. For any integers a, b, if a plus b equals 0, then b equals minus a and a equals minus b. So we can give a proof of this. Say a plus b equals 0. Adding minus a both sides, we have a plus b plus minus a equals minus a, and these two add to 0. Hence b equals minus a. Similarly, adding minus b both sides. So we began with the assumption that a plus b equals 0. Then adding minus a both sides, we get b equals minus a. Similarly, adding minus b both sides, we have hence a equals minus b. So if a plus b equals 0, then one of the numbers is the minus of the other number. Okay, this is another basic observation. and we write, fine. Recall that we write, so we can recall that we write a minus b for a plus minus b. Here, for example, 5 plus minus 3 equals 2. We write this equation as 5 minus 3 equals 2. We write a minus b for a plus minus b. So whenever you see a minus b, it is actually a plus minus b. Okay. So we can ask, what if we, so we already saw that we have two operations so far, right? For any two integers, we have a plus b and a minus a. So we have a plus b and minus a. We can look at the properties of, so we saw that a plus b, this addition operation has this commutativity and associativity property. Now we can look at the negation, so the other operation, taking minus of an integer. So we can ask, what if we take the operation twice? What is minus of minus a for any integer a? So this is another observation, negative of negative. For any integer a, minus of minus a equals a. So the proof is like we proved for, like we showed for minus of minus 5 equals 5. The proof is the same. Minus a plus box equals 0 for box equals a. Hence, minus of minus a is a. So minus of minus a is that integer such that minus a plus that integer is 0. Minus of minus a is that integer box such that minus a plus box equals 0. But we have that minus a plus box equals 0 for box equals a. Hence minus of minus a is a. Okay. So it's the same proof. Same way we showed for minus of minus 5 equals 5. It is more or less by the definition. Minus of minus a is a. Okay. Now we can ask another question. How does the negation operation interact with the addition of two integers? Observation. For any integers ab, minus of a plus b is minus a plus minus b. So we can call this distributivity of negation over addition. Let me write it somewhat to the right. For any integers ab, minus of a plus b is minus a plus minus b. So proof of this is similar whenever we're dealing with minus of an integer. So minus of a plus b is, by definition, we want a plus b plus box equals 0. We want that integer box such that a plus b plus box is 0. But a plus b plus box is 0 for box equals minus a plus minus b. Hence, minus of a plus b is, by definition, this value of the box, which is minus a plus minus b. Okay, so this is distributive of the negation operation over addition. Okay, so these are the properties. We asked what are the properties of these operations. So these are some properties: commutativity, associativity, negative of negative, and distributivity of the negation operation over addition. Okay, and let's consider one example. Let x plus 3 equals 5. What is x? So adding minus 3 both sides, x plus 3 plus minus 3 equals 5 plus minus 3. That is x equals 5 plus minus 3. That is x equals 2. So if we begin with x plus 3 equals 5, we get that by using adding minus 3 both sides, we get that x equals 2. Hence x equals 2. Okay, so I think that's all for this part. See you in the next part.